Hi, good evening, everyone. Thank you, Mr. Samuel, for that introduction. Yeah, so I'll quickly, share my screen so that we'll get started. I think, yeah, thank you. So let me know when you can see my screen.
Okay, I can see your screen.
All right, thank you very much. So my name is Asiwe Bright Asiwe. Yeah, so I'll be speaking on asynchronous Java and why it matters. So basically, this talk will run for like 25, 30 minutes so that we can use the remaining time to take questions, right? So through this course, we'll be looking into what is asynchronous programming, what is synchronous programming. Then we'll take a look at, there's a graphical comparison of asynchronous and synchronous programming. Then why we need asynchronous programming, right? And we'll head on straight to threads, then how we can create threads, thread lifecycle, problem with thread management, then the executor service, thread pool, feature, and its limitation and completable feature. So I know it's quite a long one, but these are basically that I would say they're just basic stuff, right? So it's not like we are going deep, right deep into them. So yeah, let's get started so that we can utilize the time well. So what is asynchronous programming? So it's basically a programming paradigm that allows tasks to execute independent of each other, so thereby enabling concurrent execution, improve performance. So it's just like tasks don't need to wait on each other, to achieve this non-blocking nature. So whereby you're able to run tasks concurrently, right? With that, you can better utilize your resources. So the main thread don't, have to wait for this task, to complete, right? So with this in mind, let's just, go straight to synchronous. Then we'll take some few workshops, right? Now, what is synchronous programming? Synchronous programming is also known as a blocking or sequential programming paradigm. So where tasks are executed in a sequential order, and each of the operation wait for the previous one to complete before proceeding. So this is like a big contrast between, from the asynchronous. Asynchronous it is not sequential. Tasks don't have to wait on each other to complete. They run independent of each other, right? But in synchronous programming, it is sequential. For example, you have to, for you to get to number 3, you have to count from 1, 2, 3, right? So you need to go in a sequential manner, right? So it is a blocking sequential programming, and synchronous programming may lead to reduced responsiveness and performance in application with time-consuming tasks like network calls. So, for example, you are making a DB call, or not really DB call. Since you have network calls here, so you are making like a call to an external API, right? So with your synchronous programming format, you have to wait until that task, succeeds or fails, right? So let's quickly, take a graphical representation of, synchronous and async programming paradigm. So this one is, sorry, this image, I got it from the Google. So sorry, I didn't that's put the reference here. Yeah, so here, this first one is that's a client make a request to a server. This is the party B, right? So these clients have to wait until this request either completes or fails. So there's a waiting time here, right? Then come to asynchronous. Then here is a client make a request. he don't have to wait for this request to complete. He continues doing, his other activities, until whenever this one completes and he gets his response and he continues. Oh, please, can you hear me? Can you all hear me?
Affirm, affirm.
Very clearly,
Yes.
very clearly. Yeah.
Okay, thank you. All right. So this is just like a graphical representation of async and synchronous. So the clients don't have to wait for this request, to complete, right? Now, we may be asking like, how can we even apply this asynchronous and synchronous stuff in real life events? So I have a very good example to use here. Where I live, we have this water system, right? But the flushing is not working, right? So that means if you go to ease yourself, you have to on the tap, then ease yourself, right? So there is two models there. You can either, come into the toilet, ease yourself, finish, then you now on the tap, wait for the tap to, to fill the bucket, and then you flush the toilet. Or you can choose that you come into the toilet, you on the tap while you are easing yourself. So as you finish easing yourself, then you can now off the tap and flush the toilet. So you can see these are like two models. One is that you have to wait for the bucket to fill before you flush the toilet, or you can be easing yourself while the toilet is filling up, to flush the toilet. So sorry, to use that, but that's like a very common example that I believe that we all can relate with, even if we have some non-programmers here. Yeah. So one is blocking and one is non-blocking. Yeah, so why does asynchronous programming matters? So I'm going to rush over this so that we can, start going to the workshops, right? So asynchronous programming is ideal for applications that need to handle multiple operations concurrently, especially when dealing with IO bound tasks. For example, writing and reading from database or file system, right? So for example, you have an API and your API may call to your DB. You get so if you are using a synchronous model, that means you can better utilize your CPU, you can better utilize your processor and everything, because you don't have to always all the requests coming to the system don't have to be lined up, right? Yeah. So though Java is a multi-threaded system, so yeah, you may not really have much of these issues compared to when you are working on single-threaded systems. But knowing this, kind of help you to design a better flow. High latency operation like making network calls. For example, you are integrating, some, payment gateways, right? For example, you are integrating with, money point, right? And you need to make an API call, right, to money point, maybe reserved account endpoint. So if you are on a synchronous model, that means that you have to wait until that call gets you a response, either failure or success, before you continue. But if you're on a synchronous call, then you don't really have to, that is the REST request coming to the system, don't have to wait for that request to complete, right? So these are like high latency operation. Then in real-time data processing, like stock market fees, like some of us that have done trading before, like your MT4, that's your MT5, how that live trading updates happen, right? So if you are operating on a synchronous model, you can hardly, achieve that real life stock trading stuff. So but not like asynchronous is best. There's always trade-offs, right? It depends on what you want. It depends on what kind of system you are building, right? So if you are building like a basic CRUD system, like maybe, will I say, a user management system, you may not really need a synchronous processing much in there. All right, so let me not do too much explanation because of time. So now, how can we dive into this asynchronous programming? Let's use Java as a case study. How can we dive into asynchronous programming, right? So a way to dive into it is through Java threads, right? Now, what is Java thread? Java thread is like a virtual CPU that can execute your Java code, right? So, for example, when the Java application is started, so the main method is executed by the main thread. So this is a special thread that is created by the JVM. So I won't go into reading all this, but the Java thread is it's like a virtual CPU that can actually execute your Java code, right? Now, how can we create thread? How do we, get access to this thread? What is this thread in real life, right? So this will take us to our first workshop, right? First workshop is what? Creating Java thread, right? So I will just quickly, pull out, do I have a screenshot here? But I'll just quickly, come to this demo first so that we'll see it real time here in the code. Yeah, so this is a Java, there's a Java class that extends, Java thread. That is this thread, right? So there are two basic ways, to create this normal thread like this. So you can either extend the thread class, which is this, or you can also, implement the runnable interface. But I will get to that part, right? So once you extend this, thread class, then you need to, have this run. So this run is like what actually executes, like where you put your executable, right? So, and once in this run method is where you put your runnable, that is your code, right? And you can now execute it. So let us take like a quick execution here. So this is like a demo, and here. We just want to, print out, this thread name and also compare it with the main thread name. So if I should run this, let me just quickly do this. Yeah, now I'm just trying to beat time, sorry. So let me just quickly run this, and we can use that to demo what we have here. All right. So here I have a for loop. Let me just take away this for loop so that we'll have like a basic thing here without complications. So basically what I want here is that I want to know the name of this thread and also the name of this main thread here. So let's do that. Let me rerun this, and yeah, so here now we see that we have the thread 0, which is the one coming from this thread that we extended, right? And here we have the main thread, which is, actually coming from the main JVM thread, which is like the main thread that you have, from JVM. So, as we go on, I'll see that's a build on this. This is just to like introduce us to what thread, how you can even create a thread, right? So aside from extending the thread class, you can also implement the runnable interface. So here is a demo to implement the runnable interface. So here you just implement the runnable interface and you override the run method, right? So once you override the run method, what this does is that it just creates a task for you, not a thread. This alone doesn't create a thread for you. It only creates a task. So you can either implement runnable or you can implement a callable. So you may ask, what is runnable? What is callable? So runnable is basically a task that doesn't return anything. Then callable is a task that returns something, right? So once you have this task, you now have to wrap it inside a thread. So you can see that I'm wrapping this whole task class inside this thread, right? And if I should run this, let me just give some space here so that we can have some better print here. I can see the first one wasn't well formatted. So if I should do this, you can see, let us see the thread I will have here. All right, so you can see the main thread started, the main thread completed, and this, from, this thread, this custom thread that we created here. All right, so the key point here is that we have seen the two ways that we can create a basic thread, right? But it's not just limited to, extending the class and also implementing the runnable, right? We'll see that as we proceed, that it's not just limited to those two. There's still more to them. Yeah, so here it's about to implement the runnable interface, which we have talked about. Then here is the thread life cycle. This for you to start your thread. Here we call this start here. So this start is used to actually start your thread. So you can also have the join. The join is used to wait. So, but we'll see the join as we proceed though. I'm just trying to beat time so that we'll have time to ask questions. So there is the run, this run that is, it actually contains your runnable, that's your code that is going to run. So we have the sleep and the wait. We have this other states, that is the thread life cycle. Yeah, so I'll be sharing this slide so that you can read more about it. Yeah, so that is it on the thread life cycle. This one starts it. This starts it, then call that run method that we defined here. This is the run method that we defined here, right? So it contains what we really want to run. Yeah. So let's proceed to problem 2 of managing thread. So this is a big issue. Like, thread is like the entry point to asynchronous programming, but there are some issues with managing thread, right? So, but before I come to this problem of managing thread, I just want us to go a little bit further, then come back to this, right? Come back to the problem of managing thread. Yeah, so I'm supposed to have actually put this slide, below this point, right? So what another way to also create thread, which is an improvement to what we already have, is using the executor service. I guess the executor service was introduced, is it Java 4, Java 5, something like that. But this executor service, what it basically does is that it gives us a pool of worker threads. Pick that word, pool of what? Worker threads, not daemon threads, right? So pool of worker threads. So we don't always need to create threads each time we want to, utilize a thread. We just want to have a pool of thread. So let me quickly go to that so that we can, move past that. Yeah. So here is the executor service demo. So here now, just look at this critically. I said private final executor service, then I'm saying executor.new fish thread of 10. So something is really happening here. Here I'm requesting what thread, 10 threads. You get, same way I come here to create threads, same way I come here, to create this individual thread, right? But here I'm not creating like single thread. I'm saying give me 10 threads. 10 threads that I can always reuse whenever I want to run my task. And this creates a pool of what 10 worker threads, right? Now, I mentioned earlier that this is not daemon threads, this is worker threads, in that this thread will always keep your JVM alive, right? So, and we'll see that, right? So this thread will always keep your JVM alive. After you are done running your task, it will still keep your JVM running, because these are worker threads. Worker threads always keep your JVM running unless you are using daemon threads. But we'll come to daemon threads when we enter completable feature, right? So let me just quickly run through this. So here I requested a pool of 10 threads, and here I'm submitting a task, right? So a task, that is 100 task, and this task is just going to print out task A is being performed by this, just a basic stuff, right? Basic stuff. Yeah, so let me just, let me run this and see what will happen. It's just basically going to loop through this 100 times and just give out this thing, right? But the interesting thing here is that if you look into here, you see what pool one, right? Pool one, thread one. So that means that this task I submitted here is going to be executed by just one thread from this pool, right? Now, if I should duplicate this, let me quickly duplicate this so that you see that we now have the second thread running this without us even needing to create another thread again. It's just going to simply assign this to the next thread on that pool of 10 threads, right? So let's run this and just, look around here once this needs executing. Are we together? Hello? Are we together?
Yeah. Go ahead. We can hear you clearly.
Yes, we are.
Okay, thank you. All right, thank you. Now, so take a look here. Take a look. You can see that this task A was executed by pool one thread, right? Let's go to task B. You can see it's done by what? Pool one thread two. So this task, automatically got a new thread without me, creating another thread. So this is so good in that you can always reuse thread. This is like a major improvement, a great improvement on the existing thread whereby you need to create a thread and you need to, manually handle those threads, right? Good, good. So this is it. It assigns, new threads from this pool of 10 threads, right? And if you watch, just, take a look at this, you can see that my IntelliJ is still much alive. Why? Why is it still alive? But if you watch in the other place, it died, but here it's still alive, right? Because of what? I'm using executor service, right? And this executor service creates for worker threads that keep the JVM alive. So if I want to shut down this, let us say I want this to shut down after running this. So I've made a simple method here that is just going to call shutdown. I'll just quickly run executor, demo dot what shutdown, right? So this shutdown is basically calling executor service dot shutdown. Now, if I run this, just take a look at what is going to happen here. So just take a look so that we can quickly complete this and move on to the next part. So you can see the interesting thing happening here. After running this task, the JVM actually shut down, right? Because I actually instructed the executor service to shut down. So it destroyed every worker thread that it has created, right? So there's some good to this and this, right? Because if you are, developing a module and you just want to use a SQL service and discard them, right? So you don't want to keep the JVM running, right? So you always need to call the shutdown. But if you're working on Spring Boot, Spring Boot handles all this, the thread lifecycle for you. You don't need to call the shutdown. Spring Boot is going to handle that out of the box, right? So that is it on the executor service. Then let us, circle back. So now move further. So let us aim like by 8:40 we should be done with this. So one of the major problems that we have in managing thread is race condition. I believe we all know this. We all know about race condition, right? So race condition whereby two or more threads is are trying to get hold of a shared resource, right? So there's a race condition and the final result depends on the order in which the thread executes, right? So yeah, this condition can be solved by thread synchronization. So I will get to this, synchronization. Let me not rush through this because this is like a critical point. So when two or more threads try to get access to a shared resource, you have issues. Now, I'm going to give a typical example. For example, now, you know, you want to book a seat. You want to travel from, let us say, Port Harcourt to Lagos, right? And we have just one seat remaining. And three persons are trying to book that seat at the same time, right? You have an instance, that is some cases, there is an edge case whereby three persons book same seats. So that is a problem, right? That is a big issue, right? So, and there have been ways, there have been implementations to solve that issue. For example, you have your pessimistic locking, your optimistic locking. Those are like at the DB level to handle that, right? So let us, you know, for now, you know, bring that DB knowledge into this, right? So let us say there's a counter, two or more traders are trying to, you know, to update a counter. So you will have wrong result because they are trying to update a shared resource. Now let us have a workshop, quick workshop on race condition. Yeah, so this is the race condition. So yeah, basically, I have, you know, two threads. So let me give some space so I can easily understand this. So I have this, you know, shared resource, which is a counter, good. Then here I have a method, you know, a method for increment counter. And inside this method, I've declared two threads, thread one and thread two. And what these two threads are doing is what basically to what increase this counter, right? And this one is running what 100,000 times, and this one is running what 100,000 times, right? So if both of them should run at the same time, we should expect that this counter should be up to what 200,000, right? But let us see what we'll get as the total counts. So if I should run this, let me see what we'll get. So you can see that we'll get around 15,000, right? Which is not accurate because of what these two threads are trying to what access this counter resource and update it. So you always lose count, you know, it's not always accurate, you know, update before the other, and two may try to update at the same time, and just one of the updates will go through. So that is why you don't have an accurate value here. Now, how can you solve this issue? Because this is a big issue. How can you solve it? So there are many ways to solve it. The first way that we can go about is, you know, to use synchronize. You know, synchronize is like we kind of lock this counter, right? We'll lock the update and we'll say only one thread is going to enter this counter and is going to update it. Just one thread at a time. Two threads cannot go into it at the same time, right? And how can you synchronize? So I've quickly made a method here. So that is called increase. It basically increases the counter and, you know, it is synchronized, right? This is basically, you know, locking this counter, you know, to ensure that only one thread is going to access it. So what I'm going to do here is I'm going to call the increase, just a quick one, increase, just a quick one, sorry. So I can take questions. My time is fast spent. Increase. So if I should rerun this, what do you think that we are going to get? Let me run it and let us see what to get. All right, let's wait for it. So here we get the accurate result, 200,000. Why? Because of what? We synchronized it, we locked it, right? Now, but this synchronized also has its own trade-off, because this synchronized can introduce deadlock, right? If you have, you know, a system that is a high-performance system, you know, voluminous system, you know, something that handles large requests, you know, synchronizing your shared resource can be a big issue because you have deadlocks. That is, two threads, you know, depending, you know, waiting on each other to release a lock to a shared resource. You get. So while I may not go too deep into explaining deadlock, this is just like a simple explanation of, you know, deadlock, right? So how can you, like, is there a better way, you know, to do this? Is there a better way to fix this issue? Since it's just a simple counter, we can use, you know, let us use atomic integer, right? You know about the atomic resources, right? So the entire resource is not locked, right? So it is open, it allows, you know, multi-threading, but there is an algorithm going behind the scene to ensure that, you know, this counter is volatile, and also the accurate update is always gotten. So let me quickly make this an atomic integer. If I should make it, I'll just make it an atomic integer. Then I'll come here and I'll do new atomic integer. Yeah. So if I should do that, then basically here I will say counter dot what increment get. Let me just copy this same thing over so I can quickly do this. So once I've done this, there's an error here. So I'll just comment out this since we don't really need it for now. So what I've done here is that what I replaced the normal counter to what to using atomic integer. I can see that what we still got that same resource, right? So if you are doing like simple things like counter, then you can look into utilizing atomic integer. And if it's a string, you can, I think there's something like atomic reference, right? You can use atomic reference for string, right? You just need to pass in what string, and you do that based on what you need, right? So you can see we've discussed two ways here to handle this race condition. Either we synchronize it, or we kind of use atomic integer. And if you see here, there's this this new method here aside from the start that we already know. We have this join here. Join is basically telling the whole JVM stuff to wait until this thread resolves. That is, to wait until the result comes back. So this is like another lifecycle method, right? So let's quickly jump on so that we can cover. So we've talked about race condition, we've talked about the executor service, which is another way to create a thread. So let's quickly go into features. No, okay. Yeah, thread pool, we've talked about, the thread pool, right? So basically having a pool of thread that you can always reuse, which is what the executor service, gives us, right? Good. So let's quickly jump into the future. What is future? So future comes in, when you want to get the result of an asynchronous process. That is when future comes in, right? So let me quickly go into the code base, and let's talk about future and quickly round up with future. So future is all about, how can you get access to the results of, an asynchronous process, if you supply a callable. I told you that callable is a task that returns something, right? So if you supply a callable, right, to your thread, right? So how can you get access to the results? So here now, here I have this method that is going to return a name, just a simple method. I declared a pool of 10 threads. Then here, so in this place, here I actually use one of the threads to submit a task that actually returns a name, right? So now if you watch this stuff is going to return a feature of string. So for me to actually get access to the tangible result, I need to do future.get, right? So this future.get is still a blocking process because it blocks the JVM, the main method. It blocks it until this result comes back to you, right? So can quickly run that. So it blocks it until it comes back to you, right? So this feature, it kind of, I won't really say jeopardizes, but it kind of limits the whole aim of asynchronous program, because you are still waiting for your result to come back, right? So this feature has no callback for you to use to know if your process is complete, if if there's an error. So future lacks a callback, right? And two, you always need to block. You always need to block this to get your results. So that is why I may not go too deep because of time, but future is blocking, right? Now you now ask like, how can we now achieve a complete asynchronous programming? Since future also blocks the main thread, right? Future also blocks the main thread, right? So how do we get access to our results without blocking? How do we get a real non-blocking processing? So this is where the completable future comes in, which will be the last slides. So I don't have actually, yeah. So I've talked about the limitations of feature. It is blocking operation. It has no support for callback. And callback is just like a function you pass into a function, that will execute after that function is done executing. So what does completable feature brings to the table? That is the question, right? Like we've said completable feature, like, so we've hailed it. So what does it bring to the table, right? So completable feature is the result of an asynchronous operation. It implements the feature interface along with the completion stage. So completable feature inherits all the features of feature interface, such as get, and also inherits the ability to chain task that is from the completion stage, right? So this completable feature is much like a synergy between the feature interface and the completion interface, right? So while the feature interface provides the get methods, the completion stage gives completable feature the ability to chain task, right? To chain task. So let us quickly dive into the workshop and see how we can get this complete. So good. So here now I've made a method that will basically use a completable feature to supply, to call the supply async. And it's just a simple stuff, just return a name, right? Good. But we'll see where completable feature gives us the real benefits now. Now you can see here, this is me actually, creating this class, and this is me actually, calling this get name, right? Like, take a look at this, take a look at this. You can see that this stuff now has the word, the when complete. This is a callback, right? It takes in a callback, right? So this thing checks, is the completed feature complete? Now, you now have access to the result and also the error. So you can do your normal error handling. If error is null, you can do your normal processing. X, you can do your normal error handling. So completed feature gives you a way, to know the result of your computation in an asynchronous way, right? Good. Why this one works, but there's a big issue in completed feature that we just need to take note of. Completable feature works with daemon threads, right? And what is daemon thread? Daemon threads are threads created by the fork join pool. You can take time and look into the fork join pool later. So this thread, they don't keep the JVM alive, right? So if you have a long-running task in a completable feature, you stand a chance of it not completing and your JVM will shut down, right? So I'm going to run this, then I'll just go straight to the limitations of completable feature, and we'll just complete. So the completable feature has a limitation in that it uses daemon threads, and you have to actually let me run this, please. So basically just going to print out this name, right? I'm going to print out the name bright, right? It's still basic stuff, right? What is wrong? All right, so I won't spend time on that. So that we can continue. So what is here is that completable feature, it gives us a way to actually get our result in an asynchronous manner. And I told you guys that there's a limitation of what completable feature, which is what it doesn't keep the JVM running. So if I should have something here, let us say I have a thread here, this stuff here, and okay, sorry, am I actually my completable feature stuff? So okay, this is it, sorry. So if I have this stuff which is going to run till 100, right? If I run this, you can see that the JVM may not really wait for this to complete, then it shut down, right? Oh, sorry, I have my executor service here. All right. So this is already picked up. Yeah. So let me run this. Yeah. So because of it's using daemon thread. So for you to fix that issue, you need to actually supply an executor service here. So which kind of gives you the real workout thread for your completable feature to run, to completion, right? So while I may not spend time on that because of time is far, far, far spent, but just know that if you are working with completable feature and you are going to run a long running task like maybe a call to your DB, a call to external API, you just need to supply a custom executor service here, which will supply with the needed worker threads to keep this task alive while it operates. But if you don't supply it, you stand a chance of the JVM shutting down before the task completes. That is like a big issue if you don't handle that right? So sorry. Yeah. So we've talked about this, completable feature workshop. Then we've talked about the edge case, right? So daemon threads and having to supply a custom thread for it, right? So that is it. That is the edge case workshop, right? Which is the code snippet I showed us. So it is exactly 8:47. Yeah. So this is my little presentation. Sorry, I kind of have to rush through it so that we can take questions, right? So, but this slide will be made open for everyone, so we can, yeah. So, Mr. Samuel, that is my presentation. I don't know if there's any question.
Okay.
Yeah, thank
Okay.
you.
Thank you
Yeah.
very much, Mr. Ashiwe. We really appreciate. I mean, there are lots of things I picked up from what you said. There are lots of things, and the way you actually presented it, and with the short time frame, and you were able to practicalize it. That's very wonderful. Kudos to you. Please let's clap for Mr. Bright Ashiwe. Let's clap for. I'm not seeing our emoji. Thank you, Mr. Bright. We really appreciate. We really appreciate. So, if
Thank you.
there's if there's any question, I think we can just take two questions max. So if there's any question, you can ask. Okay. I think we all understood fine and perfect. Okay. 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 That was one. Okay, so you one you can go ahead with your question. Ask your question.
Good evening, everyone. Uh, Thanks for the presentation. It was wonderful, though I joined a little bit late. But personally, I've been struggling with this particular asynchronous in Java. So I don't know if there's like a, how would I put it, documentation or a tutorial that can actually get someone started. I've actually worked with the thread and thread sleep, thread join, but then
Get you.
I've not been able to actually grasp the asynchronous part of the Java programming. So I don't know if there's a tutorial or any any tool that I can just at least make me understand it better. Thank you.
Okay, okay. Mr. Asiwi, you want to help him with that? Hello? Mr. Asiwi?
Yes. I didn't really get Ridwan's question, so I'm
Okay,
struggling to
what he was
understand what he's
asking,
saying.
what he was asking is if you have a recommendation, and we'll be dropping the record for this particular session. We'll also drop materials, and we'll drop the code base also. We'll also drop the code base you can go through. But if there is any additional material, I can also recommend that read one also that you can go through to actually fully grasp the concept of asynchronous, because as much as you went in
Hmm.
depth, you also try to remain on the surface. So if there is any material, I can also, if
Okay.
there's any, yeah.
Yeah. So there are a lot of resources online you get. So I I'll be sharing some later on the group chat, some I used to prepare this talk, right? So there are a lot of, resources on Medium. One, then also I'll also recommend the AI. AI is also your friend, right? So while I may not say you should use AI head on, but you can also use that to ask quick questions to get quick answers, right? So there are a lot of resources which I'll still share with you. All right, thank you.
Okay, thank you very much. So, see, in the absence of no questions, since there's no questions from any other person, I would like to welcome Sadoshan to just give us like closing motivation that um, to go home and think about and keep on, because Mr. Dashon is Spring Boot advocate. So when you are writing Spring, remember Sadashon again. Okay. So
Hi.
you have the floor.
Yeah. First of all, great job. I'd say you went above and beyond. In my head, these lightning talks are short and sweet. So for anybody else wanting to do one of these, you do not have to be at Bright's level. He went deep. He did a lot. He covered a lot of really great topic, and he showed a lot of great demo. He went into it and showed the code and why this really works. So fantastic job. I would give you a 9 out of 10. And the only reason I didn't give you a 10 because I think you went a little bit longer than we wanted to. But again, I was thinking lightning talk, short and sweet, amazing job. But for anybody else, the way that I'm proposing this, the way that I pitch this to others is this is our chance to learn how to present the stuff that we know. You don't have to know all the different ways, all the different lines, and have 20 examples for synchronous versus asynchronous in all the ways. You only have to talk about the stuff that you do know. Talk about what you're working on now. Talk about the reasons why you're making those things. It's not about understanding the technology deeply, even though it is a great opportunity to learn a technology deeply. What I want you to think about for your lightning talk, I want you to think about practicing the presentation. And I'm actually going to say, I want to see you present. I want to have you turn on the camera because this is about presenting. The value of being able to present your work is massive. You could be a Bright level developer, but if you can't present it, you're never going to compete with Bright. You've got to be able to present your work, no matter where you're at, whether you're at 100 level or 500 level. You've got to be able to present. So this, I want you to be thinking about your lightning talk. And I want you to be think 15 minutes is plenty. 5 minutes is enough. Be able to present something that you're working on because there's somebody else that's not doing it. They haven't thought about it for more than 5 minutes. The whole idea is, and I got this from Ian Duncan, learn today, teach tomorrow. All I'm asking you to do is teach what you're working on. And it's more about the presentation than about showing how smart you are. Does that make sense? That's my goal here is I want you to be able to present the work. And that's all I've got. Great job, Bright.
Thank you very
Thank
much.
you,
Thank you
Mr.
very much.
Dashin.
Thank you very much, Sadashan. We'll definitely take note of that. And yeah, there are people coming in for lightning talk session to actually speak, and I believe some actually got encouraged based on what you just said. So we really appreciate you. Really appreciate. Thank you very much for being here with us today.
Thank you for doing this. This is, I think, a great opportunity for everybody.
Thank you very much. Okay. I think this is what we call it a day or a night. Good night, everyone.
All right, take care.
Bye.
All right. Bye.
So we have the recording. We'll drop the recording and every material is unique.
All right. Thank you, Mr. Asiwe. We really appreciate it. Thank you.
Okay, thank you, boss. All right, thank you
Yeah,
very
thank
much.
you.